Mm-hmm.
Hello everyone, I hope you're doing well. In this video, we are gonna see that how we can draw planes from given Miller-Bravais indices in HCP. This video is a complete package, and if you really want to understand how to draw planes from given Miller-Bravais indices in HCP, I highly recommend you people to watch this video till end because it contains a complete description, every trick and tip that you should know while drawing the planes inside the HCP. After this video, you'll be expert and you can draw any kind of plane that comes to you in exam or whatever and draw it seamlessly without any confusion. So let's quickly get started. We can see there are three different kinds of examples, and I intentionally added those examples in which we have the negative z index, and I'll add one more example at the end for those who didn't watch my previous video where I did um, for the positive index cases, so that we can have complete package. So it will be like one bar, a 0, and maybe 2 here. Okay, so that it's a positive index at the end. Let's quickly get started, and first of all I'll mention the crux of all the important things that you should know while drawing the planes. Okay, and this is something that is really precious. You have to note it down because it's not available in any book, in any video on internet, so that is really rare information. Note down that information because it will help you to go through the whole method in just few lines before the exam. Points. So the first step is like to see whether we have Miller-Bravais indices or Miller indices. Okay, let's say we have the Miller-Bravais indices, which are 4 in number. Okay, H, K, I, and L. Alright, so the first is for the A1 axis, second index is for A2 axis, third index is for A3 axis, and L index is for the Z axis. Okay, you should keep that in mind. And second step is to find intercepts. These are indices, and you need to find out intercepts from these indices. And how you can do that? By taking reciprocal of indices. Reciprocal of indices. You will see by applying these simple steps, we can seamlessly draw planes inside HCP. Okay, so bear with me. Find intercepts, okay, by taking reciprocal of the indices. And after finding out the reciprocals of indices, what you have to do is to check. This is really important. Okay, this point is really important. Check if A3 intercept is equals to infinity. If A3 intercept is infinity, you have to consider A3 intercept in drawing process. Okay, if A3 intercept is infinity, then you have to consider A3 intercept into the drawing process. But if A3 intercept is not infinity, if it's any number, other number, like for example if it's 2, 3, 4, 5 or whatever, then you don't need to consider A3 intercept in drawing process. You don't need to consider. You can if you want, but it will complicate the process. You don't need to. Okay, that is not necessary. Your plane could be drawn without taking into account A3 intercept if it's not infinity. If it's infinity, you have to consider it. If it's not infinity, you don't need to consider it. A3 intercept into the drawing process. That is really important because it helps you to draw the plane really beautifully, quite accurate. Okay, so that is really important because in 2 or 3 examples you'll see that how applying this rule makes the process really easy. But if you consider it in that case also, the process is so complex that you can't handle it. Okay, so keep that in mind. That is always true. And it is also because of the fact that A1, A2 and A3 are linearly dependent upon each other, so you can always ignore A3 intercept while drawing it. But in case when we have this infinity, you have to consider it because it helps in drawing and defining the shape of the plane. Okay, so keep that in mind. After you have seen the case, the fourth step is to draw the HCP unit cell. Okay, you have to draw the HCP unit cell and then define the coordinate system. coordinate system. Okay, and by defining the coordinate system, we mean that we assign a1 axis, a2 axis, a3 axis, z axis, and then negative also, like negative a1 axis, negative a2 axis, and negative a3 axis, and negative z axis. So selection of origin is based upon the polarity of z index. It's not dependent upon the polarity of other three axis lines, but it depends upon the polarity of z axis. If the z index is positive, then the conventional origin works really well. But if the z index is negative, then you have to shift the origin. Okay, so if you can write in here z index is negative, you have to shift the origin. Okay, and if it's positive, you don't need to shift the origin. And keep that in mind. I'm telling you again and again that these three index and the polarity doesn't matter while selecting the origin. Only the z index matter, its polarity matters. If z index is positive, the origin is the conventional origin. If it's negative, if z index is negative, you have to shift the origin. And after shifting the origin, draw the plane based on the intercepts that you have got. In first two steps. This is the complete information that you need to know before drawing the planes inside a HCP. Okay, first of all, identify HKIL. Okay, and after that, find intercepts by taking simply the reciprocal. Then the next step is to check whether the A3 intercept is infinity or not. You'll check that, and you need to know that whether to include A3 in the process or not. After that, you'll draw the HCP unit cell, define the coordinate system based on the Z index polarity. And after doing that, you have to just draw the plane using the intercepts that you have got from this process. So let's quickly get started with the first one, where we have these indices, and these are the Miller-Bravais indices. This is the first plane, and let's follow the steps that I have mentioned here. First of all, we need to identify H, K, I, and L. And we can see here the first index is H, the second is K, the third is I, and the last one is L. So let's write them down in here. H equals 0, K equals 1, I equals -1, and L equals -1 as well. Okay, so this is the first step, and the second step is to find out intercepts. Okay, so let's find out the intercepts in here, and we can write in here the operation find intercepts. And for that purpose, I'm going to draw a table here. I always draw a table because it helps in visualizing, in illustrating the steps way better. So the first index, second, third, and fourth, we can write here that these are the indices in this block. And let's write down these values: 0, 1, -1, and -1. So the next step is to take reciprocal. So reciprocal means dividing by 1. So 1 divided by 0, 1 by 1, 1 by -1, and 1 by -1, and we will get intercepts at the end. So 1 by 0 is infinity, then we have 1 by 1, which is 1, 1 by -1, which is -1, 1 by -1, which is -1 as well. In this way, we have got 4 different intercepts. This is the A1 intercept, this is the A2 intercept, this is the A3 intercept, and this is the Z intercept. All right, so we successfully calculated the intercepts, and we can see the third step now, which is to check whether the A3 intercept is infinity. If it's infinity, we'll use A3 intercept. If it's not infinity, we'll ignore A3 intercept as if it didn't exist. Okay, so just like some people do to us. So it's like we can see here that the A3 intercept is -1, and it's not infinity, so we can ignore A3 intercept in the process. Okay, you don't need to mention it in here. It's like a background process that's happening inside you, so you'll ignore A3 intercept, and we'll take on A1 intercept, A2 intercept, and Z intercept in order to draw the plane inside the HCP. So the third step after that is to draw HCP unit cell. Okay, you can write it in here that since A3 intercept is not infinity, is not needed, okay, to draw the plane. You can write this statement to guide you. This is not something official, okay? Don't write it in exam. It doesn't needs to be mentioned. So you can see here the fourth step is to draw the HCP unit cell. So let's draw the HCP unit cell, and we'll draw it here. We'll draw it. So first of all, what we are gonna do is we'll draw one horizontal line, okay, and we'll draw another horizontal line that is slightly, like that, slightly before the one that we draw here, okay, just to draw it accurately. Next, what we are going to do is we'll draw some projection lines, and we'll make similar lines just below, okay. So like that, since we can see that this one is above this line, so these projected lines should finish first. For obvious reasons, we'll draw the similar length lines from this side as well. So like that. Here we'll join together these lines and we'll make the basal plane. This is the base and this is the head. And oh, sorry, this is the floor. And we'll join these lines together like that. Okay, and we'll join these lines together as well. In that way, you can see your HCP unit cell is ready, and it's really easy to construct. You have to practice it 1 to 3 times and it will be, easy to construct. And we can see here that this is our HCP unit cell. We have successfully drawn our HCP unit cell. Now the next step is to define the coordinate system, okay, and we need to define the coordinate system depending upon the polarity of Z index. And we can see here the indices that we have in here. You can see the Z index is negative, so we need to shift the origin, and we can see that this is the conventional origin. Whenever the Z index is negative, you have to shift the origin from the conventional point to a point. How does shifting happens? It's like you'll shift the origin 1 unit along the Z direction, okay, so to the other corner of the unit cell, which is this point. Okay, this is the another corner of the unit cell, and this is the new region that you will be considering for drawing the negative Z index Miller-Bravais indices inside HCP. Okay, and keep that in mind that this number doesn't matter, only the polarity matters. Okay, if it's 2 bar, 3 bar, 4 bar, or whatever the number is here, that doesn't matter. You always have to shift the origin by 1 unit from one corner of the unit cell to the other corner of the unit cell. Okay, it's always 1 unit shifting. Alright, so don't be confused. It should be negative. If it's negative, you'll shift the origin here. If it's positive, you'll work from this point. Now let's define the other coordinate axis lines. We can see that we'll assume that this is the positive A1 axis. Okay, this direction is positive A1 axis. Leaving this corner, the next corner will be the A2 axis, the positive A2 axis. Leaving this corner, the next corner is the A3 axis. We'll not use A3 axis for the obvious reasons. We know the important line that we have mentioned, that we don't need A3 axis here, but we need to know that where is the A3 axis. Okay, and we can see that this for downward is the negative Z axis, and above it will be the positive Z axis. Since our index is negative, so we will be using this axis line only. Other than that, what we need to do is, this is positive A1 axis, we need to define the negative A1 axis, which is actually this direction. Okay, just opposite to that. This is the negative A1 axis, this is positive A1 axis, this is negative A1 axis, this is positive A2 axis, this is negative A2 axis, and this will be the negative A3 axis. We don't need A3 axis, so don't need to add so much things. So that is it. This is or HCP unit cell fully prepared for drawing the plane. Okay, the coordinate system has been defined, and yes, now the next step is to draw the plane using the intercepts that we have found. And the intercepts that we have found is a1 intercept infinity. Let's write them down here. A1 intercept is infinity, a2 intercept is 1, and z intercept is -1. Okay, you can see here a3 intercept, get out. So a1 intercept, okay, we can see that a1 intercept is infinity, so keep that in mind. Infinities are always dealt at the end. Okay, we'll deal with it at the end. First we'll deal with those which are not infinity. Infinities are always dealt at the end, doesn't matter which one is infinity. Okay, so we'll take a2 intercept first, which is +1, and starting from origin, intercept is a single point. Okay, it's not a line, it's a single point. A2 intercept is 1, which means starting from origin you will move to the other corner of the unit cell along A2 direction, which is this. Okay, this line actually passes through this corner. They exactly passes through the corner point. So starting from origin we will move 1 unit along the positive A2 direction, and this is a point on the plane. Okay, this is one of the point on the plane. Now the next one is the z-intercept, which is -1. So starting from origin again, not from this point onwards, unlike directions, we have to start from origin all over again because it's intercepts, they are different. So z-intercept is -1, which means starting from origin, we'll move negative unit, which means we'll move in negative z direction by 1 unit. So from this corner to the other corner of the unit cell along z direction, which is this point. Okay, whenever we are given with 1, which means one motion means from one corner to the other corner of the unit cell along the direction whose intercept is 1, or direction of whose coordinate is 1, etc. So by 1 means from one corner to the other corner, and origin is always taken as one of the corner of the unit cell. Okay, though you can see that you might say that it's not cornered, it's a middle point, but no, origin is always taken as one of the corner of the unit cell. These are the corners. Okay, so yeah, we have this one more point on the plane. Now we have successfully found 2 points on the plane, and now we'll deal with infinity. Okay, this is one of the point, this is the second point on the plane. Now let's deal with infinity. Whenever we have infinity, we draw parallel lines from the point that we have defined already. Okay, so in either positive or negative direction, that doesn't matter, and we should extend the parallel lines up to the point so that those lines doesn't go out of the unit cell. Okay, we just stop where the unit cell stops. So you'll see how it happens. We can see a1 intercept is infinity. Where is a1 direction? You can see that this is a1 direction, this direction. Okay, this diagonal direction is a1 direction, and here this line is actually a1 direction, this line is a1 direction, this line is a1 direction, this line is a1 direction, this one and this one. Okay, you should recognize that. You can see this line is directly below this one. So these are the a1 directions. So we'll draw parallel lines from each of these points along the a1 direction, either positive or negative, that doesn't matter. So let's draw these parallel lines and see what we are gonna get. And we can see that this is the point on the plane that we already found. So this is a1 direction. Okay, as I told you, positive, negative, doesn't matter. We cannot extend this line here because it will go out of the unit cell. So we'll draw it here only, and we'll stop at the point where the unit cell ends. So we'll stop at this point. Okay, so this is a part of the plane. You'll just stop here. Similarly, you'll do the same thing here, and you can see here that this is the point, and you have this direction as a1 and this direction as a1 as well. So you will draw parallel lines in both directions, in negative a to a1 direction, sorry, and you'll stop at the other corner of the unit cell here. And from this point also, because you can see that this is also a1 direction, so you'll draw the line and you'll stop where the unit cell stops. This rule is really important to understand. Okay, you might, in confusion, have drawn it only in this direction, saying that it's positive A1 direction and we are supposed to draw it in one way only. No, this rule of drawing the parallel lines along A1 direction applies on both directions until and unless you are within the unit cell. Okay, so here we couldn't draw it this way because it's outside of the unit cell, but we can draw from this point here and this here as well because they are inside the unit cell, so we are allowed to do that. So this is the straight line and this is the part of the plane, and we'll join these points together to form a closed plane. Okay, so we'll join these points together and these points together, and this is our plane. Okay, you can shade it or whatever you want to do. Okay, you can shade it like that. So you can see here that practice is really important. Okay, you need to practice it. After that you will be confident in drawing the planes inside HCP. And I have done a ton of examples in previous video, in the previous edition, where I dealt with all those cases in which the z index was positive. All the others were mixed, but the z index was positive, so that you are more comfortable and confident about what you are supposed to do. So you can see here, okay, that this thing is really important. Another point that you got in addition to these, but this is something that you know about drawing, uh, it's about your expertise in using the logic in drawing the planes. So that is something really important, and this is how we have successfully drawn the first plane inside HCP. Now we are gonna do the second one. Okay, let's do that. Here we go with the second plane, and let's identify HKIL. Here it's H, K, this is I, and this is L. So we can see here that we have H, K, I, and L right there. Let's write them down here. H equals 0, K equals 1, I equals 2, and L equals -2. We can see that the Z index is negative. So let's do the second step, which is to find out the intercept. Find intercepts. We'll do it using this table. Alright, so we have indices here, H, K, I, and L. This notation is arbitrary. You can use U, V, T, W, whatever. Okay, that is not something you should care about because it's, your own selection. Since I use this notation in all of my videos, that is why I'm just continuing with this notation. So it's 0 first, then we have 1, 2, and -2. Now the next step is to take reciprocal. Okay, reciprocal, dividing by 1. So 1 by 0, 1 by 1, 1 by 2, 1 by -2. Okay, and we get intercepts at the end. 1 by 0 is infinity, 1 by 1 is 1, 1 by 2 is 1 by 2, and 1 by -2 is -1 by 2. This is A1 intercept, this is A2 intercept, this is A3 intercept, and this is the Z intercept. And you can see here that the A3 intercept is not infinity. Okay, since it's not infinity, we can ignore A3 intercept. Okay, so that is something I'm doing it in rough. You don't need to do it on paper. Okay, don't do that. So we'll use A1, A2, and Z intercepts to draw the plane. Now the next step is to draw the HCP unit cell, and then we'll define the coordinate system. Okay, so let's draw the HCP unit cell. Let's draw it here the similar way we did before. So we have this straight line, one more straight line slightly before the previous one. Let's draw these projection lines. Okay, it will stop here, and this one will stop a little farther away. Okay, now let's join these together. Okay, next we'll close the figure like that. Join these corners together. Okay, And in that way our figure has been drawn. As we have seen that we have drawn the HCP unit cell, now the next step is to define the coordinate system, and we'll define the coordinate system depending upon the polarity of z index. And we have seen that the z index is negative here. Since the z index is negative, so we'll be using this point as origin. Okay, that is something now we are comfortable with. So we know that if the z index is positive, we'll use this basal point as origin, and if the z index is negative, we'll use this point as origin. So here we'll be using this point as origin. Okay, let's define the coordinate axis line. So we have this one that moves through this corner as the a1 axis. Okay, leaving this corner, the next corner, this is the a2 axis. Leaving this corner, this is the a3 axis. And yes, in that way we have drawn the three axis lines, and this is the negative z axis that will stop here. Okay, this is the negative axis, and this is the origin. You can write it as O. And next we need to draw the negative axis lines as well, because they are also needed in the process. So this, if this is the positive a1 direction, this is the negative a1 direction, this is positive a2 direction, and this gives you the negative a2 direction. A3 is not needed, so we don't need to draw it. Alright, so in that way we have defined the coordinate system. Now let's write down the intercepts here so that we can draw the plane. Okay, the last step, as we can see here, is to draw the plane based on the intercepts that we have got in the initial steps, which is infinity again here. Then we have a2 intercept, which is 1, z intercept, a2 intercept, which is 1, z intercept is minus 1 by 2. Okay, this is minus 1 by 2. So we'll deal with infinities at the end. First we'll draw the points which are not infinity. A2 intercept is plus 1, really easy. So starting from origin, we'll move 1 unit along a2 direction, which means from origin to the other corner of the unit cell along a2 direction. Okay, so it's like here, this is a point on the plane. Okay, we can highlight it. This is one of the point on the plane. Next we can see that the z intercept is minus 1 by 2. Okay, so let's see that how we can find out this point which is minus 1 by 2. So starting from origin, what does 1 unit, okay, what does minus 1 corresponds to? First of all we'll see this, and then we can take half of it, which will be minus 1 by 2. Okay, this is the standard method that we use to find out those fractions of 1. So we have this point starting from origin. Again we'll draw minus 1 unit, which is to the other corner of the unit cell along the z direction, which is this negative z direction. Okay, this whole length makes it 1. Okay, you'll cut it into half. You can use ruler or something like that for accurate cutting, but this is where the half of it is located. So from origin you'll move here minus 1 by 2. This is the point, this is the minus 1 by 2 point with respect to origin. Okay, with respect to origin, not from this point. Keep that in mind. Always starting from origin, you'll move minus 1 by 2 unit, which is this point. Okay, so this is another point on the plane. Alright, and we can see here that the a1 intercept is infinity. Again, it's a kind of similar situation to this one, but the z intercept was different. And we can see where is the a1 direction. We can see this diagonal line is a1 direction. Okay, and here you can find out this diagonal line like that. You can, you know, produce it like this diagonal line that passes through this point, so that it will help you in, you know, extending those parallel lines, because this is where, okay, like that. Okay, I hope you are getting my point. We'll draw this diagonal line just like this is, so that you know where is a1 direction. So when the intercept is infinity, you draw parallel lines from the point that you have already found, such that they do not move out of the unit cell. All right, so let's do that. And we can see here from this point, this direction, this is a1 direction. Okay, we cannot extend it in the negative a1 direction, because it will move to in outside of the unit cell in that way. So that is not allowed. We only draw parallel lines so that they are inside the unit cell. Okay, so we'll draw a parallel line along a1 direction, which is this direction. This is a1 direction, 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 this is a1 direction. Keep that in mind. So we'll move from this point and we'll stop at this point because that is the end of the unit cell. Okay, so this is a part of the plane. Now we can see this is another point on the plane. So we'll draw a parallel line along a1 direction, either negative or positive, that doesn't matter. Okay, so we'll draw a parallel line first in positive a1 direction, which is this, and we'll stop at the other corner of the unit cell, which is this point. This is the corner of the unit cell. Okay, because you can see this is the line, this is an original line that defines the boundary of the unit cell. So we'll stop at there. Similarly, we'll draw from this point onwards in negative a1 direction as well, because it's inside the unit cell. Since that condition is satisfied, we can draw the parallel line in this direction as well, since it's also a1 direction. So we'll stop to the other corner of the unit cell, which is this point. Okay, we can't do this thing here for the reason that if you do it right here, it will move outside of the unit cell. This is outside of the unit cell, but here they are inside of it. Okay, this is inside, the whole length is inside the unit cell, so you have drawn it. Now join these lines together like that, and this one with this one, and you have drawn the plane in that way. This is the plane. Okay, this is the plane 2 whose Miller indices were, let me see, it's 0, 1, 2 and 2 bar. Okay, and this one was 0, 1, 1 bar, 1 bar. Okay, so you can see here the situation. Let's do the third plane, which is 1, 1 bar, 0 and 3 bar. We can see that we have 0 in here, so the A3 intercept will be infinity here, and we'll see the difference. A slight difference in method, like we have an additional intercept to take into account. Let's do that. This is the third plane, and we can see this is H, this is K, this is I, and the last one is L. Let's write them down. H equals 1, K equals -1, I equals 0, and L equals -3. Okay, so the next step is to find out the intercepts. And for that purpose, we'll draw the table again. Here we have the indices H, K, I, L, 1, -1, 0 and -3. We'll take reciprocal. By taking reciprocal, we will get intercepts. So 1 by 1, 1 by -1, 1 by 0, 1 by -3. So 1 by 1 is 1, 1 by -1 is -1, 1 by 0 is infinity, and we have -1 by 3 here. So these are the intercepts. This is A1 intercept, this is A2 intercept, this is A3 intercept, and this is the Z intercept. Alright, and we can see here that the A3 intercept is infinity, so we have to incorporate the A3 intercept into the process. Okay, so all of the 4 indices will contribute and will help us to draw the plane which is defined by these Miller indices, these Miller-Bravais indices. So let's do that. Let's draw the HCP unit cell first, and for that purpose we'll draw these horizontal lines. Okay, one more slightly before it, we'll draw these projection lines. Longer is better. Okay, let's join these two together. join these together. So this is the HCP unit cell, you can see. Okay, the next step is to define the coordinate system based on the polarity of z index, and we can see that the z index is negative. Okay, so we'll take this point as origin. This is our origin. Okay, if the z index is negative, this is origin. If z index is positive, this point is the origin. So this is our origin. Now define the coordinate axis lines. This is the positive axis, a1 axis, leaving this corner. This is positive a2 axis, leaving this corner. This is the positive a3 axis. Okay, and since this is positive a1 axis, this is negative a1 axis, positive a2 axis, this is negative a2 axis, positive a3 axis, this is negative a3 axis. You know, a3 axis is it's gonna be used here in this method, so we need to define the negative a3 axis also, and this is the negative z axis. Okay, and this is the origin. This is our origin. So let's draw the plane using the intercepts that we have here, and let's write down these intercept here. 1, this is -1, this is infinity, and the last one is -1/3. We'll deal with infinity at the end. So first of all, we'll deal with the non-infinity terms, which is a1, a2 and z intercept. Okay, so what is a1 intercept? It's 1. So starting from origin, this is the positive a1 direction. Since it's positive, so we'll move in positive a1 direction. Starting from origin, we'll move 1 unit along the positive a1 direction to the other corner of the unit cell. So this is the point on the plane. This is the point on the plane. Okay, now the next intercept is a2 intercept, which is -1. So this is positive a2 direction and this is the negative a2 direction. So it's -1. So starting from origin, we'll move 1 unit along negative a2 direction to the other corner of the unit cell, which is this point. This is another point on the plane. All right, now the next intercept is z intercept. Okay, infinities will be dealt at the end. Z intercept is -1/3. So starting from origin, first of all, we'll draw the one length, then we can divide into 3 equal parts to get -1/3. Okay, so we will from origin to the other corner of the unit cell, this length is equals to 1. Okay, divide it into 3 equal parts. You can use ruler to do that. It's like 1 equal part, and this is like that. Each length is 1/3 and -1/3 since negative direction. So this is 1/3. This is -1/3. This is -2/3, and this is -3/3. 3 cancel, so this is -1. Okay, this is how you calibrate. So this is -1/3. So this point on the axis line is the third point on the plane. Okay, -1/3. Now we have 3 points. Another important thing that is needed here is that we have a3 intercept as well, because a3 intercept is infinity, so you have to take it into account. All right, so a3 intercept is infinity. So from the points that we have found, we'll draw parallel lines in a3 direction. Okay, such that the lines are within the unit cell, they do not go outside of the unit cell. Okay, so this horizontal direction is actually the a3 direction, either here or here. Okay, positive negative doesn't matter when we are drawing the parallel lines. Okay, that is something that you already know. So from this for these 2 points, you can see that this is the horizontal line which is parallel to a3 direction. If we draw for this point, if we draw a parallel line in this direction, it will move outside of the unit cell. You can see that this is the corner. This part is not okay here. So you cannot move in this direction because that's the corner of the unit cell. If you move outside, you are moving outside of the unit cell. So you are not supposed to move in this direction, but this is the parallel line, and you will stop at the other corner of the unit cell, which is this point. Okay, which is also a point, already a point on the plane, but okay, this point. For this point, this is also the line that you can draw. So this is the only line that we get from these 2 points. Okay, so yes. Now for this point, which is right at the middle, Okay, we'll draw parallel lines along the A3 direction, which is horizontal lines. Okay, so we'll draw a parallel line from this point like that, horizontal lines, and we'll stop at the other corner of the unit cell, which is this point. We will not stop here or here because this is behind the center. Okay, this is the center line, you know, this wall is behind the center, so it is not lying here, and this wall is in, you know, is lies in front of this center wall. So this center, if we draw horizontal lines, corresponds to this wall. Okay, I hope you get it. In case of A1, we were dealing with these walls. Okay, these walls and these corner points and the lines that are corresponding to these corner points, you can see here. Okay, in previous figure, if you are confused like where to end, you can see that we were supposed to find out draw the parallel lines along A1 direction. So these are the corners of A1 direction. These two are the corners of A1 direction, and the projected lines that are with this corner are the points where you are supposed to stop as well. Okay, if it would have been infinity for A2 direction, so you would have drawn the parallel lines along these projected lines because they correspond to the A2 corners. Okay, since we have the infinities corresponding to A3, so A3 corners are these 2 points. Okay, we can see the A3 corners are these 2 points, so we are supposed to stop at these lines. Okay, if you're confused, that would help you a lot in visualizing it. So we stopped here, not here or here, because no, that is not what we are supposed to do. So we'll stop here, and from this point in the negative in this is the negative A3 direction, we'll also move in this A3 direction because this is also included. So we'll stop here. Okay, so these are also now the points on the plane. We cannot move any further any other way because they will go outside of the unit cell in that way. So that is what we have as a result. We'll join these lines together like that and fill it up, and this is the plane. This is our third plane, which is 1 bar 0 3 bar. Okay, this is the plane. I hope you got the method. It was really simple. And let's do the fourth one, in which we have A3 intercept to be infinity again and the Z intercept is positive, so that you have that example as well, and you will completely understand how to draw the planes inside a HCP. Okay, so you don't have to watch, you know, different videos for understanding the method for the positive Z index type of, you know, so it's in one example. And if you have already watched the previous video, you can skip this example. At the end, I'll mention that how you can convert the Miller indices into Miller-Bravais indices. Okay, so that you can, if you are given with Miller indices and you are supposed to draw the plane inside the hexagonal unit cell, then you are supposed to find out the Miller-Bravais indices first, so that you may know that what is actually the A3 intercept. Okay, because that is needed. You can see here that if you wouldn't have considered A3 intercept, the shape of the plane would have been entirely different. It would have been this, which is not correct. Okay, so you will see, I'll mention it at the end for those who don't know. Okay, this is the last one, and we have, this is H, this is K, this is I, and this is L. H is equals to 1, K equals -1, I equals 0, and L equals 2. Let's find out the intercepts. Draw the table. Indices H. H is 1, K is -1, 0, and this is 2. Taking reciprocals. So 1 by 1, 1 by -1, 1 by 0, 1 by 2. This way we'll get intercepts. It's 1, it's -1, 1 by 0 is infinity, and this is 1 by 2. We can see here that the A3 intercept is infinity, so we have to consider A3 intercept into the drawing process. Okay, so this is A1 intercept, A2 intercept, A3 intercept, and this is the Z intercept. Okay, and we'll consider all of these intercepts in order to draw the plane in HCP. Let's do that. Let's draw the HCP unit cell. Let's draw the unit cell here. So the projections, here the projections, little downward. Okay, joining these lines together. Now we'll join these two corners together as well. This is the completed unit cell. We have drawn it. Now we need to define the coordinate system, and the coordinate system is defined based on the polarity of Z index. We can see that our Z index in this case is positive, so we'll be using this point as origin. This center point is our origin. Now let's draw the axis lines. This is positive A1 axis. Okay, leaving this corner, this is positive A2 axis. Leaving this corner, this is positive A3 into axis. This is A1 axis. This one is the negative A1 axis. This is positive A2 axis. This is negative A2 axis. Positive A3, negative A3. Okay, and this vertically upward is the Z axis. All right, so we have successfully drawn our hexagonal unit cell, and now it's time to use the intercepts to draw the plane. Let's write down those intercepts here so that we can quickly use them. A1 intercept, A2, Z intercept. So A1 intercept is 1, A2 is -1, A3 is infinity, and Z is 1 by 2. Okay, so if we have infinity as A3, so we'll deal with it at the end. Let's use these non-infinities one first. So A1 intercept is 1, which means starting from origin, this is positive A1 direction since it's positive. So starting from origin to the other corner of the unit cell along positive A1 direction, which is this point. So this is the point on the plane. This is the point on the plane. Now A2 intercept is -1. So starting from origin in negative A2 direction to the other corner of the unit cell is this point. So this is the point on the plane. Next is the Z intercept, which is half. So we'll draw one length first, okay, which is from origin to the other corner of the unit cell along Z direction, positive Z direction, which is this point. Okay, this is where the corner is. So we'll divide it into half. This length is 1. We'll divide this length into half, which is this roughly. Okay, so this is 1 by 2, and this is another point on the plane. All right, now the A3 intercept is infinity. So what we are supposed to do here is to draw the parallel lines from these points that we have found, and in the A3 direction. A3 direction, you can see, is the horizontal direction. The simplest direction is A3 direction. So from this point onwards, we'll draw parallel line along A3 direction, which is this direction, like that. Okay, to the other corner of the unit cell. So we'll stop here. Okay, we can't move further because it will move it outside of the unit cell. We can't move outside. So for this point also, we cannot move it in this direction. We can only move in this direction, which is the same line that we get for this. So we don't need to do it for them separately because it's the same common line. For this point, we'll draw horizontal lines along A3 direction, which is this, and we'll stop here, because these are the A3 corners, and the line of A3 corner, the line joining the A3 corner is this line. Okay, this line. So we'll stop at this line, this brown line. So for this one as well, we'll draw parallel line along A3 direction, which is this point. Okay, so we can see that we have got a straight line here and straight line here. Just join these together like that through a straight lines. Okay, you can shade it and this is actually your plane. This is actually your plane. What does this aunt is doing here? It's 1 bar, 0 and 2, and we can shade it. You can see it was really simple. Just a bit of practice and you are good to go. Alright, so this was the last plane. Now let's see how we can deal with Miller indices if they are given, and how we can convert them into Miller-Bravais indices. Let's suppose that you are given with Miller indices now, like 0, 1 and 1 bar. Okay, so you are supposed to convert them into Miller-Bravais indices first, then you can draw the plane inside the HCP, because Miller-Bravais indices are needed. So this is H, this is K, and this is L. Okay, I is missing. Only I is missing. Keep that in mind, that the H of Miller indices and the H of Miller-Bravais indices, K of Miller-Bravais indices, L of Miller indices and Miller-Bravais indices, they are same. There is an additional index only that we need to calculate. In case of direction, they are different with each other. Okay, they are different from each other. But in case of planes, these three indices are similar to the Miller-Bravais indices. Okay, and vice versa. So only I needs to be calculated, and I is equals to minus of H plus K. Okay, so for example, here H and K are given. We know that because, okay, so minus H is 0 plus K is 1. So it's minus 1. You can see 0 plus 1 minus 1. You can see that is also the case here, because I took H, K and L of this one, so I obviously will get I of this one. So this is I, and we can write these Miller indices into Miller-Bravais indices like that: H, K, I and L. I will be in between K and L, so we can write it as 0, K for 1, I that we calculated, which is 1 with a bar on it. Okay, L the same. Simple as that. And you'll use the same method that I described in this whole video, and you can, go with it. Okay, that is really simple. For example, you are given 2, 3, 1 as Miller indices. You'll find out I, this is H, this is K, and this is L. I is missing, so it's minus H plus K. Minus H is 2 plus K is 3, brackets here, minus 2 plus 3, which is 5. I is 5, so it's actually 2, 3, 5 bar and 1. This is H, this is K, this is I, and this is L. Okay, in that way you have converted it into Miller-Bravais indices, and now you can use it to draw the plane. Okay, so it was really simple. And in some other instances, what happens is that they write it like that: 0, 1 dot 1 bar, and dot is actually I, and you will find out I using the same formula, minus into H plus K. That is really simple. Sometimes what happens is that they shift the dot, for example, like it's in first place. You know that it's the place for H. You can find out H from this formula again. You can take it like negative here, H plus K. You can take K in this side, so it's I minus K equals H. If you know two of them, you can find out the third one. Okay, that is the beauty of Miller-Bravais indices. Okay, so that is really simple. I hope you got it. Like, share and subscribe, and let me know if you have any questions, or if you want me to make some other videos on some other controversial topics. So take care and goodbye.